prefer. Okay, so have you downloaded the software? Share. Okay, have you downloaded the software? No?
On the way.
On the way. Okay, 4 gig, right? Around
Downloading.
4 gig, right? Okay.
Yes.
Okay, so never mind. Okay, so today is just the introduction of the software. Oh, sorry, I forgot the password. Okay, so this is the link that I have given to you. So make sure you take 13.0 SP1 and also light version. Light version. They have light. Three versions lah. Okay. Light. And what else? Subscription. Okay. So you take the light one. Okay. And then combine file. Okay. Click the combine file and download all. Okay, so you will have around 4.4 GB lah, gig. Okay, so if your internet is quite slow, so maybe you take you need a longer time lah to download. Okay, so after you download, you need to unzip the file. Okay, unzip the file. So this is my downloaded file, and then this is my unzip file. Okay, so this is the unzip file lah. So you can see the unzip file, setup and components, right? And then you can click setup. Okay, never mind, I can click again for you. Okay, click setup and install the software. Okay, if my laptop is quite slow lah, so that's why I have installed earlier lah. Okay, and then after you install, okay, yes. Okay, and then you can get this interface lah. Okay, so just press next, accept. Okay, and okay, location you want to install. So because I've already installed, so I don't have to install lah. Okay, because install takes around half an hour to 1 hour. Okay, so now I've installed. So then I open my software. Okay, there are quarters 2. Okay, so create new project. Okay, create new project. Okay, so you will get this GUI. Okay, next, for example, today we will do multiplexer. Okay, multiplexer. Okay, I'm not sure whether the notes is here or not. Okay, hold on, I'm opening the notes for you. Okay, so if you see the notes, you can get the code lah. Okay, I've given to you the code to write the multiplexer. Okay, so you will see the notes yesterday. Tuesday. So about multiplexer. Okay, share. Okay, so this is note for multiplexer. So we want to write the code of multiplexer, which is I think this one. Okay, so we will try to do this one, 2-to-1 multiplexer. 2-to-1 multiplexer. Okay, so this is the code lah for 2-to-1 multiplexer. Okay, so I want to write this code, okay, on my Altera. So then first, if you see this interface, you need to put into your folder. Okay, so if you press next, by default it will be included in the 13.01 folder. Okay. So 13.0 SP1 folder is the software folder. Okay, so which it is not good to mix your file and also the folder. So I create separate folder. For example, I create 2-to-1 marks. Okay, 2-to-1 marks. Okay, so 2-to-1 marks folder. Okay, so now your folder is in 2-to-1 marks folder. So name of folder, so name of project. Okay, name of project must be same with your code. Okay, for example, your code here, the module name is MUX21, right? Okay, capital MUX21. So your project name must be same, MUX21. Okay, MUX21. Okay, so module MUX21. If your project module MUX or 221, okay, up to you. Okay, what name you want to label, but this name must be similar with your module name. Okay, otherwise you will get the error lah. Okay, MUX21. Okay, if you want to name it as MUX2 MUX221. Okay, this one can be capital or small letter lah. MUX221, for example. Okay. But if I give this name, I need to change this code to same name, MUX221. Okay, clear Okay, so this is very important lah. So I change to MUX21. Okay, MUX21. Okay, then next. Okay, you click next. So this one you can skip lah, next. Okay, now time you have to choose your hardware. Okay, you have to choose your hardware because in the lab, okay, maybe in future you will come to MJIIT lab. Okay, so in our lab we use Cyclone 2. Okay, Cyclone 2 board. Okay, so Cyclone 2, you can choose uh, anyone lah. Okay, anyone that suitable. Okay, for example, I choose this one lah. Okay, the first one. Okay, so Cyclone 2 specific device, I choose the first one. Okay, but this one, you need to check the name of the board. For example, this board I choose EP2C5F256A7. So in the box, in the hardware box, they will give you the name. Okay, but because this one is just a simulation, I just pick any name lah. Okay, but in real life, when you want to use the board, you need to check the name of your board. The serial number. This one name and serial number of the device. Okay, because different name will give you the different specification. Different core voltage, different LE. LE is the logic elements. User IO is the input output. Memory also different. Embedded multiplier 26, PLL and PLL and global clock. Okay, so if you choose different numbers, they will give you different apa requirement. Okay, so it will give you different value. Okay, for example, I choose the simplest one lah. Okay, so next. Okay, now design entry synthesis. Okay, so this is where you select your tool name. Okay, so this is the tool name. So you have design entry. So this one, I think should be none. This one none. Simulation. Okay, simulation you take model sim Altera. Okay, model sim Altera, you take Verilog HDL. Okay, remember that yesterday I told you about Verilog VHDL, right? So we use Verilog HDL. Okay, model sim Altera is the tool to run your waveform. Okay, when you complete your project, you have to get the waveform. Okay, so waveform is the output and also input signal that you give to the chip or IC. Okay, so the rest none lah. Okay, the rest none. So this one only you select. Okay, so far okay. Okay, so next. Okay, so this is the mm, value. Okay, value that come out from your specification. Finish. Okay, so now you create the Verilog file for this. Okay, so click this one, new. Okay, okay, this one the white paper one. Okay, new. So you click new. So you select Verilog HDL file. Okay, new. Okay, on top and also left. Okay, you select the Verilog HDL file. Okay, select Verilog HDL file. Okay, okay, okay. Okay, now you can write your code. For example, I already copy the code. Okay, where is module? Okay, no module. Okay, never mind lah. I just okay this one. Okay, just write module marks 21. Okay, so input and output. A I0 I1 Z. A capital A I0 I1 and Z. A I0 I1 Z. Okay, then semicolon. Okay, semicolon. Input A I0 I1 semicolon. Input A I0 I1. Okay, output Z. Okay, Z, make sure if you use capital Z, you have to use capital Z here. Okay, okay, input A I0 I1, output Z. Assign Z equals to, okay, assign Z equals to not A. Not A and I0 or A and I1. Okay, from where we get this code from previous slide. Okay, from this slide. Okay, from this equation. Okay, from this module. From this module, we convert to the mathematical part. Okay, so we assign Z equals to not not A and I0 or A and I1. Okay, so I copy to assign Z equals to not A and I0 or A and I1. Okay, so next is I think end module. Okay, end module. Okay, end module. Sorry, I think end first. End module. Okay. Okay, then you save. Okay, marks. Make sure you save the same name as your module. Marks 1. Okay. And then you press play. So see display button. Start compilation. Okay, now you compile. Oh, error. Okay, error. Okay, error. Okay, module. Okay, still error. Okay, so this one end module. Okay, maybe no end. Okay, it's okay. Should be okay. Okay, successful. Okay, so far clear. So first step lah. Okay,
Clear, Doctor.
clear Umairah Okay, kalau if too fast, you just call me lah Just let me know too fast. Okay, so run. Now you already run the Verilog. Okay, now successful lah. Error 0 warning is okay lah Warning never mind. Just make sure no error. Okay. So this is your Verilog code. I want to show you the circuit. The circuit gate level simulation. Netlist viewer. I think this one netlist viewer. Okay, so this is your circuit, right? Okay, same with the node, right? Okay, same with the node. This one lah. Same with this one. Not A, not AND gate, OR gate. Okay, A, so this one not. Okay, so this one not. A not, and OR gate. Okay, so where I get this one just, you cannot change this one. This one based on your code. Okay, automatically. You don't have to draw this one. Even you cannot draw. Okay, draw is the different file. Draw is the I think you have to select different this one, gate level. Okay, gate level file. Okay, but this one are very log file. So when you want to capture your circuit, okay, you can go to tool, netlist viewer, and RTL views. Okay, tool, netlist viewers, RTL viewer. So you can see the circuit that you have programmed using Verilog. Okay, this one automatic ah. Okay, if you want to change here, you need to change the code. Okay, you need to change the code. Okay, so next we go to the waveform. Okay, so click new. Okay, now your code already okay. So you want to run the waveform. So click new, click Verilog HDL. Click University Program VWF. This one. Okay, new University Program VWF. It comes out with this one. Okay, so this is your template for your simulation. Okay, so this one you go to the press your mouse cursor, okay, to this side. Okay, this side. Okay, can you see the mouse? Okay, and then double click. Okay, double click this one. Double click the mouse on this side. Okay, so this is mouse. So I double click. So I press double click. Okay, and then it will come out with this one. Okay, and then you node finder. Okay, node finder. Okay, node finder, because we want to find the input and output of your uh, diagram. Okay, your program. Okay, so I repeat again. This one, go to this one, double click. So you get this one, node finder. Insert node or bus, you click node finder. Okay, node finder, and then click list. Click list. Okay, so it automatically will display you the input pin and output pin. You can see IN, right? IN are the input. Put out is the output. Okay, so I select all. This one I click A, and then I click shift and go down. I click shift, I click arrow down to select all. Okay, select all and then move all to the right. Okay, because you want to select. Okay, want to select input, and one output. Okay, click OK. Okay, make sure from left you must see on your right. Okay, otherwise you don't select anything lah. Okay, so now okay. So now your input and output are already on this simulation waveform editor. This is the template for simulation waveform editor. You can see the input now. Input for A, I0 and I1, you put at 0. This one line 0, right? If 1 is here. Okay? Okay, bigger. Okay? If your signal is 1, your signal will be here. For example, I change the signal to 1. So now 0, I change to 1. 1. See? Okay? So now I change the signal to 1. You only can change the input signal. Output signal you cannot change. Output signal will be changed after you press simulation here. Okay? You run the functional simulation. Okay? Only then you can get the output. Input only. Okay? Input only. So input. Okay? Input of multiplexer. I set from this table. Okay? From this table. Okay? For example, this one. Okay? I have I1, I0, and A. So I select 0, 0, 0. See from this table, right? Okay, I select 0, 0, 0, this first row. Okay, so I select 0, 0, 0. My output is 0, right? So we will see from the simulation whether we get the 0 or not. So I change to 0, 0, 0. So how to select 0? You click A, you select 0 here. Okay, 0 or 1. You want to force to 0 or 1. Okay, for example, I force to 0. So 0, 0, 0. Okay, and then I click run functional simulation. Okay, functional is the simulation when you do AND, OR, XOR. Okay, that are the functional simulation. Timing simulation when you want to do mixer, okay, you want to combine the waveform and so on. Okay, generate model sim, we don't use this in this class yet lah. Okay, run functional first. Okay, you run functional simulation. Okay, now save your changes. Okay, yes. Okay, and then you save the name. Okay, for example, I save name is as marks21. Marks21. So I save, click save. Okay, I save as marks21. Okay, and then it is running now. Okay, now the simulator is running. Okay, oh, error. Model sim. Okay, should be okay. Oh, okay. Okay, so this one I select option, I select quarters 2 simulator. I think model sim should be okay, but I'm not sure why today cannot. Okay, maybe I do some problem or I need to restart the laptop. Okay. Okay, so this is the output. See, input 0, 0, 0, you get output Z is 0. Okay, easy lah, 0. So we check or we test the bit for one, okay. For example, this row, 101. 101, make sure you see I1 is 1, I0 is 0, A is 1. So you get the output as 1. So we test 101. Okay, 101. So you cannot change the input here because this is the output. This is the simulation waveform editor for output. Read only. You can see this one read only, right? So you cannot do changes here. Okay, just close lah. Okay, just close. Okay, if you want to print screen, you print screen for your result. Okay, otherwise this one back. Okay, so I change to 101. Okay, I change to I1 is 1, I0 is 0, A is 1. Okay, 101, I will get the output as 1. Okay, so 101. So this one 1. So I click I1. I1 is 1. So I click I1, I press 1, force 1. Okay, I0 is 0. So leave it 0. A is 1. So I click, I press 1. Okay, so now I run functional simulation. Okay, save. Okay, same name. Okay, so this is the output, which is Z is 1. Okay, so same, right? Our note. Okay, 101 will get the output of 1. Okay, so 1 you need to check this one. I1 I1. Okay, to make it easier, maybe you can sort it lah. Sort it based on this table. Okay, because this table shows I1 I0 A. So I change I1 to 1. So this one you just drag. You just drag. Okay. So I1 you just drag. So I1, I0, A. So just click and then you just drag where you want to bring that input or output. Okay, so I click I1, I0 and A to follow the table. Okay, so 1, 0 and 1. So your output will be 1. Okay, run, you get the output of 1. Okay, so one more for you, one more. 1, 1, 1. Okay, for example, the bottom one. 1, 1, 1, you get the Z as 1. Okay, so I change to 1. This one already 1, this one 1, this one 1. So 1, 1, 1. So I get the output of 1. Okay, see whether we get the output or not. This one. Okay, so my output Z is showing 1. Okay, 1, 1, 1. Output is 1. Okay, so far okay. So far, anyone? Okay, or has anyone already write the code? Okay, if you have written the code and try to run and then you test the waveform, maybe you can post into our group lah. Okay, you can post in our group. Okay, so that I can see someone can complete this task lah. Okay, so I give you uh half an hour lah. Okay, half an hour until 4 to write this one and run the code and also waveform. Okay, if you have problem, just let me know lah. Okay, and you also can share the output lah on the WhatsApp group.